this is Josh White with JW Math Tutoring. In today's video, I'm going to cover the 5 hardest problems from the October 2025 ACT Math exam, Form J08. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Before I start this ACT Math video, I just want to take a couple seconds and let you know about my Improve Your ACT Math Score course, available on both Udemy and Teachable. The course features a wide and comprehensive review of ACT math topics, including how to use both the TI-84 and Desmos graphing calculators. It also includes general strategies, such as back-solving and picking numbers, and a review of topics in algebra, geometry, probability and statistics, and other miscellaneous topics as well. It includes over 10 hours of instructional videos and over 20 total hours of videos, including solutions to various problems. So please check out that video if you're looking for more help on improving your ACT math score. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And let's go ahead and get started with this video. I just want to mention 2 quick things before I start covering these 5 hardest problems from the October 2025 ACT Math Exam Form J08. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only covering 5 problems from this particular test is because in the past I have been hit with copyright strikes or violations on my YouTube channel from ACT Education Group for going through the solutions to an entire test. So that's why I'm only allowed to do 5 problems from this exam. Alright, so with all that being said, first question I want to highlight is number 21. So you see in this one, you have a square, you also have a diagonal, you got a circle inscribed in it, and they want to know the area of the shaded region. So the fastest way to do this problem is to notice that the radius of the circle is 8. Okay, so that means this is 8, this is 8. That also means each side of the square is 16. So I would start off, I would find the area of the square as just 16 times 16, which is going to be 256. Then I would notice this sector of the circle and this little outside part here together form a triangle. In other words, they form a triangle either right here or right here. You could look at either one, it doesn't matter, but when you add them together, they make up the area of the triangle. Therefore, the total white area is going to be 1/2 times base times height. Well, the base is 8, and the height right here, or right here, is also going to be 8. You know, because you could draw a radius here, and it's just going to be the same length. So if we go ahead and do that, 1/2 of 8 is 4, 4 times 8, 32. Now you can just subtract these. That will leave you with the shaded area. So let's see, we are going to get 224. Correct answer is going to be letter C. Now, you could also technically think about the problem this way. I think it's more complicated to do this, but you could technically find the white area, basically what I have, colored in yellow, by finding the area of this sector. So that would be, pi r squared, which is the area of the entire circle. It's going to be 64 pi. And then multiplying that by 45 over 360, because this angle right here is going to be 45 degrees. And the reason is because in a square, the diagonal forms, the diagonal makes an isosceles right triangle. So therefore, this is 45, this is 45. So you could go ahead and you could do that, and that would give you just the area of this sector. Then you'd have to find the area of the triangle down here, and then subtract the area of the sector. So in other words, you'd be doing 32 minus, 64, erase all this, 64 pi 64 pi times the 45 over 360. That's the area of the small white part. The small white, outside part. And then you would just add that to the inside, the area of the sector, which you found. And notice what you're doing is you're just, like, the 64 pi times the 45 over 360s basically cancel out, right? And you're just left with 32. It's like you're taking 32, you subtract this sector away from it, but then you add the sector back in together, and you just get the same answer. So if you want to think about it that way, that's fine, but it's just, a little bit extra work in terms of the calculation. All right, next, let's look at question number 27. So here's one where you have to do a volume calculation. That in and of itself, not that difficult, but then you have to do a unit conversion, then you have to do a third step after that. So this problem basically has 3 different steps or calculations that you have to do. So first thing, volume of a cone is given. It's pi over 3, and then times the radius. Okay, so they tell us here the radius is 3 squared times the height, which is 2. So if you go ahead and calculate this out, it should come out to approximately 18.85 inches cubed. Now, I'm going to do my calculations just in Desmos for 2 reasons. First of all, it's, for this video purposes, faster and quicker than using it, on-screen TI-84. But second, Desmos is now allowed on the digital version, online version of the ACT. So I'm recommending, to all my students that they take the online or digital version of the test. Therefore, they would have Desmos available to do the calculations instead of needing to use a graphing calculator. Of course, you're still welcome to use a physical graphing calculator, but I think it's much faster and easier to use Desmos. Okay, so there is our volume. I'll just define it as V so I can carry through the calculation. All right, next we have basically a conversion factor here for a weight to a volume. And what we're going to do with this is determine how many pounds, based on the volume that left, how many pounds is that equal to, which left. First of all, that leaked out of the bag, and then we have to subtract that to see how much is left in the bag. So we're just going to do the 18.85. I'm just writing this as the approximated version, but I'm going to use the exact version in the calculation. And now, since it's a unit conversion, okay, I want the 1 cubic inch to be on the bottom right here, the per cubic inch, that goes on the bottom, and the 0.025 pounds will go on top. And now these will cancel out, and this will tell me, I multiply them together, so I'm going to take V and multiply it by 0.025. Okay, so approximately 0.4712 pounds is the amount of sugar that leaked out of the bag. Notice that's not what the question is asking for, and you also don't see it among one of your answer choices. The question is asking for how much sugar was left in the bag after the leak was fixed. So now we have to go back and notice we start with 1.5 pounds, so we're going to subtract the 0.4712 from that. That's going to give us the answer of how much is left in the bag. So I'll just jump back to Desmos, and all I need to do now is I just need to go 1.5 minus that. Okay, 1.02876, and notice when we look at the answers here, it's very close to 1.029. So that's our correct answer. Correct answer for this one is going to be letter B. Next question I want to highlight is actually the one directly below this. I'll slide down here just to get rid of some of the writing on the screen. Okay, so for this problem, basically, we have a polynomial that's being expanded, and they tell you the second term is 8x cubed y. How many total number of terms will there be in this expansion? So the basic rule, the basic shortcut that you're going to use here is the number of terms when you have a polynomial, being multiplied out, is equal to the power, or the degree that it's being raised to, plus 1. And just to show you this real quick, if you're familiar with Pascal's triangle, the way it gets set up is this. Okay, so here, this is the level where you would have, say, like whatever, x plus y squared, or we could do by, it doesn't really matter. Okay, notice here, when it's squared and you multiply it out, you FOIL it, you get 4 terms, but 2 of them combine in the middle, because they're like terms, so you end up with 3 as your answer. So notice the power is 2, but the terms are 3. And then the next one, x plus by to the third, or cubed, you end up with 4 terms here when you work it all out. Okay, and then if you keep going, x plus by to the fourth, you end up with 5 terms. So, going back to the problem, notice here I have 8x cubed y. Each of these terms also will have the same degree in total, because there's an x and a y, as the power up here. So in other words, for the x plus by squared, each term is going to have a total degree of 2 among all the variables. And same thing for the cubed, each term is going to have a degree 3. So here, the total degree is just 4, because we have a 3 plus a 1. Therefore, this is going to basically be this level right here. This is going to be x plus, this is, in other words, this is going to be the result of x plus by to the fourth, which means there's going to be 5 total terms, so the correct answer is going to be letter A. And I mean, I guess you could like practice, you could just, if you had time, multiply these all out on the test, just to confirm and see, but you don't need to do that. I mean, the terms are just going to be x to the fourth. Second one's going to be 8x cubed y, and then plus blah 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 x squared y squared blah 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 xy cubed plus blah 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 y to the fourth, and so on. And so in any case, correct answer is going to be letter A. Okay, next up, question 34. I'm actually going to zoom in on this one just because the diagram is pretty small here. Okay, so when looking at this one, you have an isosceles triangle, which is like the overall large triangle. And then you have a smaller triangle inside of it here, DEH, and then even smaller triangle inside of that, FGH. Okay, you're told that D and E and H are all midpoints. What that means, or how that helps you, is the following. Also, so you're also told F and G are midpoints. Okay, there's a theorem in geometry, which is that when you have a triangle and you have a line segment which goes through the midpoints of 2 sides of the triangle, then you know 2 different things. You know that first, the 2 sides are parallel. Okay, you know that this midpoint segment up here is parallel to the third side. And more importantly, what we're going to use in this problem, you know it is half the length of the third side. So in other words, if this is 5, this is 10. You know, if this is 2, this is 4, and so on. This is the property that we're going to use to solve this problem. So, the way you would look at this is the following. Okay? I know F and G are midpoints, okay? So if you look at this triangle DEH, that means that FG is going to be half the length of DE. So say this is 1 and this is 2. Then we turn around and we look at DE, which goes through some midpoints here. Now, since we know this is an isosceles triangle, we know that I can just mark these all the same. DE is half of the third side here, AC. So if I said, just hypothetically, DE is 2, that means AC, the whole thing across here, would be 4. Now, notice the ratio of the sides for ABC to FGH, again, just the side ratio, is going to be 4 to 1. In other words, AC here is 4, FG here is 1. Okay, so corresponding sides in ABC is 4 times larger than that in FGH. Now, because we want the area, which is two-dimensional, we have to square this. Essentially, this is the scale factor. The scale factor is 4 to 1. So for the area factor, we take the scale factor and we square it. So 4 to 1 squared becomes 16 to 1. The correct answer for this problem is letter C, right here. And that's how you work your way through it. All right, let me go back and look at the last problem now. It is, here we go, 39 at the bottom of the page. So this is a percentage problem. Let's zoom in so this one's a little bit larger. All right, so multiple ways you could do this. First, you could do it by hand, which I'm going to show you. Then second, I'll show you how to do it in Desmos. And third, you could also do it by picking numbers, which that's kind of essentially what the Desmos version is doing. So 40% of m is equal to a. So a is equal to 0.40 m. b is equal to 7 over 10a. b is equal to 0.7a. Which of the following gives 112% of m in terms of b? So we're going to first, before I do that, we're first going to get an expression for m in terms of b, and then after that we're going to do 112% of it. I'm just going to multiply. So m is equal to, divide by 0.40, a over 0.40, or that's really just equal to 2.5a. And again, this you could just confirm in the calculator, 1 divided by 0.4 or 100 divided by 40. All right, so now what I'm going to do is I'm going to divide this by 0.7. So a is equal to, just look at my notes here. It's not a nice decimal value because it's technically 10 over 7. Yeah, it's 1.429. So I'm just going to approximate it, but I'm going to, of course, use the exact value in my calculations. So now we can plug this in for a, and we know that m is equal to 2.5 times 1.429a. Sorry, not a, times b. It should be b. Okay, and now now we want 112% of m. So we're going to multiply this by 1.12. We're going to multiply the entire right side by 1.12. And this is going to be our answer, whatever we get. So now, again, I'm just going to go to Desmos to do the calculation. It's going to be 2.5 times this number, which was technically 1 divided by 0.7, and then times 1.12. Notice because I use the exact value, it comes out to 4. Therefore, 112% of m, or 1.12m, is equal to 4 times b. And that's our answer. So the correct answer for this one is going to be letter A. So now, let's see how you could solve this problem entirely in Desmos. So what I'm going to do is, in Desmos, basically, it's solving a system of equations using regression is essentially what I'm doing. If you want to know more about how to do this for advanced percentage problems, check out my Ultimate Desmos Guide to Digital ACT Math. I will put a thumbnail on the screen showing you which specific video covers this topic. All right, so we've got the first equation, which is basically 40% of m, and then that is going to be equal to a. So those are the first two things in my brackets. And then the second equation is b is equal to 7a over 10. Now, notice the problem here is that it's just giving me 0 for everything, and therefore it's not really telling me, 112% of m in terms of b. It's not really giving me the answer. So what I'm going to have to do is I'm going to have to define one of the values just in the beginning to not be 0, and then it should hopefully calculate everything correctly. So let's say I'm going to take a, and let it equal to 1.2. Okay, now what I'm going to do is just calculate 112% of m. Okay, so notice I have that number 3.36. Now I just look at the answer choices and I see which of those is equal to 3.36 based on the b value. And you can just type it in. For example, 4b, 3.36, there's our answer. Okay, but if it wasn't, you could also check 12b, okay, you could check 40b, or you could check 84b. So that's it. That's how you can solve this problem entirely in Desmos. Now, I do want to take you through a slightly different approach. I mean, it's really using kind of the same basic concepts. I mean, it's basically using picking numbers, and I'm going to use Desmos for the calculations, but it's not quite the same as what I just showed you. So if this approach that I'm going to demonstrate now is more comfortable or easier for you to understand, then just go ahead and do this. That's fine. So basically, we know that we have the equations, right? We know that we have, so let me just erase some of this stuff here. Just pretending as if we're solving this, from scratch. Okay. So again, we've got 40% of m is equal to a, and then we've also got the b equals 7 over 10a. So here's how I would do this in terms of picking numbers. I would say, all right, I am going to let m equal whatever, 100, okay? Then a is equal to 40, we can actually just do it this way, 40% of m. Okay, so a is equal to 40. And then we know b is equal to 7 over 10 times a. All right, so b is equal to 28, right? So now what I need to do is find 112% of m, 112% of m. Okay, it's just 112, and the whole reason I chose 100 is because you actually can quite easily look at that and just figure it out, because 112% is just going to be that exact number because I started with 100. Regardless, which of these answers now is equal to, taking my b value, which is 28, which of these answers is equal to 112? Okay, 4b, slide this up. So notice, again, that's my correct answer right there. 4b is equal to 112. You can check the others, not 112, not 112, not 112. Okay, so this is just an alternate approach that you could use in Desmos. Again, using the basic strategy of picking numbers. I hope you enjoyed this ACT math related video. If you did, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you're looking for more practice in improving your ACT math score, please check out my course, Improve Your ACT Math Score, on both Teachable and Udemy. There are direct links to the course on both sites listed in the description and pinned comment of the video. Otherwise, good luck as you're preparing for the ACT math test.